Jai Hind student, I am Dr. Anand Tyagi from Ajay Kumar Garg Engineering College, Ghaziabad. Today I am going to deliver my lecture on Engineering Mathematics First KAS 103T. Today I explain the module 1 and topic rank of the matrix. First of all, I explain what is rank and what is the role of matrix and what is the role of rank in the matrix as well as in our daily life as well as our engineering and technology. So keeping in the mind, rank play the most important role our engineering and technology. First of all, module 1 matrices. Contents of the today lecture are rank of the matrix and how to calculate rank and what is the role of rank, and second, echelon form, with the help of echelon form how to calculate rank of the matrix, and third is normal form and how to calculate the rank with the help of the normal form. So this is the contents of the today lecture. Student, keeping in the mind, this play the very most important role in our technology. And another is system of the equation, how to solve the system of equation with the help of the rank we study here. Now reference of the book AKGEC Advanced Engineering Mathematics, Marais de Ware and B.B. Ramanna and B.S. Grewal. Student can be opt any one of them for the reference book. Now first of all, what is rank? A non-zero minor of order R is said to be rank of the matrix whose all minor of higher than order R are vanished. Suppose we have a matrix of order 3 by 3. First of all, calculate the rank of this matrix. How to calculate? The first method is determinant. First calculate the determinant. If determinant are non-zero, then its order is called rank of the matrix. This is the matrix of order 3 by 3 and it have the minor of order 2 by 2, right? This is the minor of 3 by 3 and this, right? So rank of this matrix depend on its determinant. First of all, we calculate the determinant. A student studied how to calculate the determinant of a square matrix in the 12th level, and there is another method to calculate the rank of a matrix. I explain here. Suppose I write here 1 1 1. This is the first column, this is second column, 1 2 1 1 0 2 here, and first and second column is repeat here 1 1 1 1 2 1. Now first of all, cross this line and multiply this line. That means 2 into 2 4 into 1 4. I write here, right? And product of this is 0 plus 0 and product of this is equal to 1, all these element, minus in the same way 2 2 ja 4 and this is 0 and 2 1 ja 2. So in this way we can find the determinant of the square matrix. In this way we can calculate. Suppose our aim is calculate the rank of the matrix. So first of all, we consider here the determinant of this matrix is non-zero, then rank will be 3 here, because rank of this matrix is depend the order of the rank. So order of this is 3, so rank of given matrix is 3. Suppose we consider the another example here. Let A is equal to this matrix and order of this matrix is 3 by 3. First of all, calculate the determinant of this matrix, right, and that is 0. That means rank is not equal to 3. So rank may be 2, rank may be 1 here. So how to calculate? So consider a minor of order 2 by 2. So how many minor of 2 by 2 here? First of all, see very carefully. So this is the first minor of order 2 by 2 and determinant of this minor will be 0. 2 2 ja 2, 1 ja 2 and 2 1 ja 2, that means 0. And this is the another minor of order 2 by 2, 2 2 ja 4 minus 2. So this is the non-zero minor and this is 0 minor. So we can say that there exists a non-zero minor of order R, right? So that means we can say that rank of this matrix will be 2 here, because rank of this matrix is 2 by 2, right? So in this way we can calculate here the rank of the given matrix and easily calculate the rank of matrix. Now minor of order 2 by 2, consider the total number of minor of order is, this is the 2 by 2 here, 2 by 2 minor, this is this minor and this is also 2 by 2 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 minor here. So that means there exist 2 by 2 minor 1, 2, 3, 4, 5, 6, 7. But see, we see here determinant of this 2 by 2 matrix will be 0, and determinant of this 2 by 2 minor will be 0, and determinant of this 2 by 2 minor will be 0. But this is a minor non-zero minor. This is a minor non-zero minor, because determinant of this 2 by 2 matrix not equal to 0. In the same way, determinant of this matrix is not 0. So we can say that rank of this matrix will be 2 here. So in this way we can calculate the rank of a matrix by using this method, and this method is known as determinant method. In the same way, rank of the matrix, how to calculate rank of the matrix I explained just now. Now what is the role of matrix and how to calculate the rank of a matrix, this is the most important point. So there are 3 methods to calculate the rank of a matrix. So first of all, determinant method. If determinant of a matrix, right, is non-zero, that means rank of this matrix will be the order of a matrix, right? But drawback of this matrix, this method is that suppose order of matrix is 4 by 4, order of matrix 5 by 5, right? That is a critical problem how to calculate the determinant. And secondly, this method cannot be applied when the matrix is in the rectangular form. Suppose matrix is in the form of 2 by 3, then how to calculate, right? So this method is used only in a square matrix. Then now next is another form is echelon form. What is echelon form? I explain in the next slide, and how to calculate the rank of a matrix with the help of echelon form. And another is the normal form. I elaborate one by one here, right? So first of all we see that one question, and by the given example, and this question arises in the GATE exam 2022, right? So I solve this example with the help of the rank. What is the problem? Problem is that find the value of A, rank of matrix A is 2, right? How to calculate? So there are method to calculate the determinant of this matrix, and we can calculate the rank of this matrix. So we can calculate here, if rank of this matrix is 2, that means determinant of order 3 by 3 will be 0 here, right? Because rank is 2 here. So that means, and order of this matrix is 3 by 3. So first of all calculate the determinant of this matrix. So determinant will be 0 here, right? And I put up the value of determinant is equal to 0 and calculate the value of A in this place, and calculate the determinant of 3 by 3 order matrix, and this will be equal to 0, and value of A will be 2 here. So in this way we can say that if rank of this matrix is 2, the value of A will be 2 here. So in this way we can calculate the rank of the square matrix, maybe 2 by 2, maybe 3 by 3, maybe 4 by 4. Another form is the echelon form. What is echelon form? A matrix A, Aij, is said to be echelon form if the number of zeros of the preceding the first non-zero element of row increase row by row until only 0 remains same. That means, and this is also known as another name UTM or LTM, lower triangular matrix and upper triangular matrix is the another name of the echelon form. But there is a silly difference between UTM and echelon form. I explain here. Suppose I have a matrix of order 3 by 3, right? This is the principal diagonal of this matrix, right? And all elements below the principal diagonal are 0 here. So we can say that this is the upper triangular matrix, right? And calculate the rank by using the number of non-zero rows. So there is the another definition of the rank. I explain here what is rank by the echelon form. The number of non-zero rows in echelon form is called matrix of the matrix, rank of the matrix. So how to calculate? This is the another criteria, by using the elementary row transformation, by using the elementary column transformation. But first of all, student keeping in the mind how to calculate the upper triangular matrix and lower triangular matrix, and then how to calculate the echelon form, right? There is another echelon form, all elements below the principal diagonal. So rank of this matrix will be how many, depend on the how many number of zeros here. So there are two number of zeros, 1 and 2. So rank of B here 2. In this case, how many number of non-zero rows? So there are 3 number of non-zero rows in A. So rank of this matrix will be 3 with the help of the echelon form. So student keeping in the mind when we calculate here, so first of all, how to calculate the echelon form? By using the elementary row transformation. We see here very carefully, right? In this way we can say that rank of this matrix is equal to depend the number of non-zero rows, right? And number of non-zero rows is 3. So rank of this matrix is equal to 3. We consider here the another method to calculate rank of the matrix by using the echelon form of a matrix. So first of all, how to reduce a given matrix into echelon form? First of all, so by using the elementary row operation or operation convert into the given matrix into the echelon form, maybe row operation, maybe column operation, and count the number of non-zero diagonal as element of a non-zero rows and calculate the rank of a matrix. The rank of given matrix A is equal to number of non-zero elements, a number of non-zero rows in the matrix. If we use elementary row operation, it is called row echelon form. If we use the elementary column operation, this is known as the column echelon form. So there are two type of echelon form, row echelon form and column echelon form. In the same way, first of all, I explain here how to calculate the rank by using the echelon form here. So first of all, we consider example here 3 by 3 matrix. So first of all, we reduce into echelon form. So how to? So first of all, we see that this is the first row and this is the second row and this is the third row. First of all, with the help of this element, we reduce second row into 0. How to? So I apply here R2 arrow, R2 minus 2R1. So what will be the result here? First 2, 3. First 2, 3. First row is as it is and I apply 2 minus 2 is 0 here. 1 minus 4 minus 3 here. 0 minus 6 minus 6 here. In the same way, right? 0, 1, 2 right here in the same way, right? So next, how to calculate the next step in this way? So first of all, I divide second row by minus 3. This is the second elementary row operation I apply here. Now what will be the result? First row is as it is and second row is divided by minus 3. So result will be 0, 1, 2 here and third is 0, 1, 2 here. Last two row, second and third are same. The result will be here R3 arrow, R3 minus 2 and result will be 0, 0, right? And first of all, we see that all elements below the principal diagonal are 0 and diagonal element contain unity element. That conclude that what is the rank of this matrix. So first of all, count the number of non-zero rows. So number of non-zero rows here, first row, second row non-zero rows. So rank of this matrix will be 3 here. So in this way, we can calculate the rank of this method matrix by using the echelon form, which is the depend on the number of non-zero rows and that is equal to 2 here. So in this way, we can find out the rank of a square matrix by using the elementary row transformation, convert into echelon form. Now we consider here another example of this row 1, 1, 1 and 1, 3 minus 2, 1, 2, 0 minus 3. How to calculate the echelon form of this matrix? So first of all, I apply here R2 arrow, R2 minus R1 because our aim is reduce this into 0, this into 0 and this into 0 with the help of A11, right? Yeah, right? First element of the first row. So how to apply these operation, right? I explained just now and apply one by one. So what will be the result here? We see very carefully. When we calculate the calculation, so first of all, we apply the operation and all operation apply together, right? Suppose there are 4 by 4 matrix, so 3 operation multiply together. First of all, so how to apply? first operation, second operation and third operation. So student keeping in the mind all three operation apply together. So first apply this R2 arrow, R2 minus R1. So 1 minus 1 0 here, 3 minus 1 2 here, minus 2 minus 1 3 here, 1 minus 1 3 here. In the same procedure we apply on the third row and we apply on the fourth row. In this way we calculate here, right? Now our aim is, this is the diagonal element of this matrix, right? Our aim is reduce this element into 0 with the help of R22, second row, with the help of second row. So we apply here R3 arrow, R3 plus R2. This is known as elementary row operation. So what will be the result here? First row as it is, right? Second row as it is. If we add this into this, so result will be 0 here, right? Minus 5, minus 3, minus 8 and 0 here. In the same way third row right here same, right? So first of all we see that how to calculate the result and how to calculate the matrix here. Matrix is depend on the number of operation. So how to calculate? So first of all we divide third row by minus 8, right? I apply this line, and fourth is divided by minus 3. So what will be the result here? So result will be here, right? 1 1 1, first row is same, second row is same, and this is divided by previous line, and this is will be equal to 1. In this way we can calculate the result. Now our aim is reduce all elements below the principal diagonal R0, right? So first of all reduce this element into 0. So how to calculate we see very carefully, right? So I apply here R4 arrow, R4 minus R3. So this will 1 minus 1 is equal to 0. So I write here. Now finally description is that all elements below the principal diagonal are vanished, that means 0. So this is the echelon form, and number of non-zero rows is here 3. So rank of this matrix will be 3. So in this way we can calculate the rank of a square matrix. With the help of echelon form we can calculate the rank of a rectangular form here easily, right? Suppose I want to calculate the rank by using the normal form, right? This is the another method, and this method is also known as canonical form, and this method is also known as RC method. That means row and column both are applied together in this procedure. So suppose, right, what is normal form? First of all I explain here. A square matrix in the form of IR. IR means identity matrix of order R, right? So there are 4 normal form: IR, IR0, IR0, IR0. This is called the normal form, and rank of the matrix will be here R, right? So first of all how to calculate the rank of a matrix? The rank of a matrix is A is R if and only if the matrix A can be reduced in the normal form. This is all forms are known as a normal form, and in normal form student can apply row and column transformation together, right, by using the elementary row transformation as well as elementary column operation. Now we see that convert into a given matrix into normal form and find the rank. So suppose we consider here, this is the example to consider here how to calculate the normal form, right, and how to calculate rank. So first of all we see that order of this matrix is equal to 2 by 4. So we consider here, right, first of all we consider in which 2 and 4, 2 is the minimum. So we consider here this is the diagonal, consider diagonal, and below this all elements should be 0 here. How to calculate? First of all we see that, right? So first of all we apply here elementary row operation. So first of all I apply here R2 arrow, R2 minus 2 R3, right? So suppose we apply here, the first row is same, 2 minus 2 is 0 here, 3 minus 4 here 1, 4 minus this and 5 minus this is equal to the right. In this way we can calculate the value of this, right? How to calculate? We see that, right? So we see that how to calculate. So this is the very most important rule by using the column operation. After applying the row operation, a student can apply direct column operation. So this will be the time reduced system here, right? How to calculate? So we apply here this to reduce into 0 with the help of first column operation, right? So I apply here C2 arrow, C2 minus 2c1. Second row column operation, c3 arrow c3 minus 3c1, and next operation c4 arrow c4 minus 4c1. In this way we can calculate the another form, right? This is known in the form of this reduced to 0, 2 minus 1 0 here, 0 1, 3 minus 1 0 2, 4 minus this and 0 2, right? So in this way we can calculate this format by using the elementary column operation. Now with our aim is reduce with the help of this element, this into 0, right? How to? By using the column operation c3 divided by 2 and c4 divided by 2. What will be the result here? The result will be this here, right? With the help of this element, this reduce into 0 and this reduce into 0 by applying the column operation c3 arrow c3 minus c2, comma c4 arrow c4 minus c2. So in this way we can find out the solution of the problem and how to calculate rank of this matrix we apply here, right? So this is known as partition of this matrix, and this is known as I2, and this is known as the 0 matrix of order 2 by 2. That means this is the normal form of this matrix, and rank of this matrix will be 2 here. So student, keeping in the mind, when we solve the problem, to first take the decision, we apply here normal form or echelon form. So right, first of all student apply echelon form. Normal form is apply only when to do ask it, find the normal form and calculate rank. Otherwise student apply the normal echelon form, because echelon form takes the minimum time, right? Suppose I consider here another example. I write a matrix here 1 2 3 4 and 5, right? This is the first row. Second row 2 3 4 5 6, another 3 4 5 6 7. Now our aim is reduce into normal form. So then how to calculate? First of all I apply here R2 arrow R2 minus 2R1. This is the problem, right? So how to apply here? First operation 1 2 3 4 5. This is the first operation, right? How to calculate? 2 minus 2 0, 3 minus 4 minus 1, 4 minus 6 minus 2, 5 minus 8 minus 3, and this is minus 4. Now another operation is apply here R3 arrow R3 minus 3R1. With the help of R1 reduce all the zeros, right? How to apply here? So we see that, right? So 3 minus 3 is 0, 4 minus 6 minus 2, this is 5 minus 9 minus 4, this is minus 6, and this is minus 8. And last two rows are identical, right? So last row reduce into 0 form 1 2 3 4 5, right? Another is divided by minus 1 1 2 3 4, right? And last row will be 0 because R2 and R3 are identical, right? Now with the help of this element, all column operation apply and reduce into 0 form. So what will be the result here? So C2 arrow C2 minus 2C1, first result is this. So what will be the result here? 1 0 0 0 1 0, and apply the another operation C3 arrow C3 minus 3 C1, right? So what will be the result here? 0 0 and 0, right? And all column operation are 0 here, 0 0 0 0 0 0. That means partition of this will be 0, and this is the form of I2 0 0 and 0. So which is the normal form, and rank of this matrix will be 2 here. So in this way we can find out the normal form of any matrix and calculate the rank of the matrix by using the normal form. So student, keeping in the mind when we solve the problem, right? So this play the very most important role in our calculation. First of all, reduce the given matrix into normal form and find the rank of the matrix. This is the another problem, right? So first of all we consider here R1 interchange by R2, right? Because there should be one here. With the if there should be one, I can calculate the easily the echelon form here and apply the row operation here, right? How many row operation apply? So 1, 2, 3, 3 operation apply together. So what will be the result here? We see that. So the first row is same, and this is the result of by applying this result. And how to calculate the rank? So we consider here with the help of column, apply column operation here, and this element reduce into 0 form. This is 0, and with the help of this is also 0. With the help of this is equal to 0. In this way, we can find out the normal form and calculate the result. In this way, we can find out the normal form by using the elementary row operation. I apply here R2 arrow R2 minus R3, and result will be this. Now apply R3 arrow R3 minus 4R2, so this result will be 0 here, right? And how to calculate? We see that, right? And third row and will be divided by 11, and column operation can be applied here. C3 arrow C3 plus 6C2. So with the help of this element of the column, second column, we reduce it into 0, and what will be the result here? Result will be there. And third column divided by 33, and this is divided by 22. So what will be the result here? We see that result will be this. Now our aim is reduce into this with the help of this element. So this minus this will be 0 here. I apply the operation C4 arrow C4 minus C3, and this will be the final result, and this is known as normal form of the given matrix, right? And this is known as I3, and this is known as 0, and this is known as 0, 0. So this is the normal form of the given square matrix, and rank of this matrix will be 3 here, right? So in this way, we explain here what is the rank and how to calculate rank with the help of echelon form and with the help of a normal form. Now, what is the role of the rank in our engineering and technology? We see here, right? Suppose another question, find the value of A and B such that rank of the matrix is 2. We cannot apply here the determinant method because order of this matrix will be 3 by 4. So we cannot apply here the determinant method. So there are two options. So first is echelon form and another is the normal form. So I apply here the echelon form. So first of all, I apply here R2 arrow R2 minus 2R1, right? And apply here R3 arrow R3 minus 6R1. So with the help of this, 2 minus 2 is equal to 0 and 6 minus 2 is also equal to 0. So how to apply this operation? We see that, right? So 0, 5 minus 7 and this, right? So this is first of all our aim is reduce all element below the diagonal element. So in this case, diagonal element will be considered here this, right? So this is the diagonal of 3 by 4 matrix, and we reduce all elements below the diagonal element is called 0, right? In this way we can calculate this form. Now question is that rank of this matrix is 2. That means there exist 2 non-zero number of rows, right? Because rank of this matrix is 2, right? Initially I explained what is rank. So number of non-zero rows in a matrix is called rank of the matrix. So there should be 0 and there should be 0, right? So what will be the result here? A minus 4 is equal to 0, a b minus 6 is equal to 0, a is equal to 4 and 6. So in this way we find the value of a and b with the help of the non-zero rows या echelon form. Another problem is how to calculate the rank of a linear system of equation. Linear system of equation can be solved with the help of the rank. How to calculate? So first of all, linear system of equation divided into two parts. First is non-homogeneous and second is homogeneous. Student study the linear of system of equation in 12th level as well as student study in BTech level. But how to calculate and what is the drawback of the 12th method? Why we study this method and why we study the rank of the matrix to solve the linear system of equation. So with the help of rank, we can calculate the linear system of equation. Here we can optimize the linear system of equation. So there are two types of linear system of equation. First is non-homogeneous and second is homogeneous. If system is homogeneous and non-homogeneous, how to calculate the rank? First of all, I calculate here C with the help of AB, and this is known as argument matrix of A, right? If rank of C is not equal to the rank of A, then that means system is inconsistent. No solution of this system of equation. Suppose rank of C is equal to rank of A, that means system of equation is consistent, solution is possible. If solution is possible, then solution may be linear, may be unique, or may be infinite. If rank of A is equal to rank of C is equal to n, so we can say that system of equation have a unique solution. If rank of A is equal to rank of C but less than number of variable, so we can say that system of equation have infinite many solutions. So today I explain all of you the how to calculate rank, what is the role of rank, right, what is rank, right. In this way today lecture I explain each and everything in details, how to calculate rank, and some illustration here by using some example of the rank. In the next lecture I explain the linear system of equation and how to solve the linear system of equation with the help of the rank. So today lecture, if a student have any problem, so they can be contact me my WhatsApp number, and I explain their queries one by one. Thank you all of you. I hope today lecture you have the hopeful and you got good enjoyed. Thank you all of you.